One.
So we've been talking a lot about what the term congruent means. In fact, we've talked so much about it, we've used it in proofs, we've talked about congruent segments. What I want you to do is take a moment, define congruent. Okay, so do that, submit that, and we'll continue with the video. So hopefully you defined congruent to be equal in measure. Okay, and when we dealt with segments, that meant that, two segments, if AB equals CD, then we could say that segment AB was congruent to segment CD. And we did that with angles too. If the measure of angle ABC equals the measure of an angle, call it XYZ, then we could say that angle ABC was congruent to angle XYZ. But when we talk about shapes, it's more than that, okay? Talking about shapes being congruent, in layman's terms, in simple basic terms, we can say that the shapes have the same size and shape. And we say size and shape, but that really means a little bit more than just size and shape. Because when we talk about the size, what we're really talking about, when we say, hey, they have the same size, what that means is that the sides are congruent. When we say shape, we mean that the angles are congruent. So we have to be a little careful. Same size and shape is sort of a layman's terms. It's not a real mathematical term, okay? So basically, when we're talking about two triangles are congruent, if the corresponding angles are congruent, that gives us same shape, and the corresponding sides are congruent. That gives us the same size, okay? So take a moment here, answer a quick question. So moving back, when we look at this, these are two congruent triangles. Corresponding sides, AC is congruent to FD. That's what we mean by corresponding sides. So I can see that AC is congruent to FD. I can see that BC is congruent to FE. Okay, with the angles, I can do the same thing. Angle A corresponds to angle D. So angle A is congruent to angle D. So forth and so on. Angle B is congruent to angle E. There are angles that correspond to each other, that match up. Okay, so still using the word corresponding, but it's a little different than when we talked about corresponding angles of parallel lines. Here's the catch. When we name these congruent figures, make sure that the matching angles and sides line up. Okay, so in this case, if I call, however I call the first one doesn't matter. Triangle ABC will be congruent to triangle. Now I have to match them up. So angle A matches angle D, angle B matches angle E, and angle C matches F. Because now I can see that the angles match up. A matches A, B matches E, C matches F, and I can see the sides. AC matches FD. They're in the same place. AC, FD, or DF. BC and EF, or FE, same place. So that's going to be true. So when I'm naming any kind of figure, given this, then I can conclude that angle AED is congruent to what angle? Angle XW is congruent to what side? Okay, answer that real quick. So hopefully you said AED will be congruent to angle VZY. You can actually just match them up, or YZV. Angle XW will be the same as CB, or side rather. Okay, so you're just sort of matching up the letters and making sure you know what's what. Now, when we go to prove these things, there are a total of 5 ways to prove triangles are congruent. And we're going to look at all 5 of those methods. Okay, the first one, and I'm just going to go through these and we'll discuss them more tomorrow. First one is called side, side, side. And it basically means, sometimes we'll abbreviate it with SSS. It means that the 3 sides match up. So there's 1 set of sides matching up, 2 sets of sides matching up, 3 sets of sides. So I have to say, if I find AB matches PQ, AC matches up with RQ, and lastly, BC matches up with PR. Then triangle ABC is congruent to triangle, let's see, make sure I get this, A to B, so that's A, B, and C. So that's going down 1 and then 2, so QPR. There we go. That's side, side, side. That's the easiest one. The next one is side, angle, side. Abbreviated SAS. And in this case, the angle has to be between 2 sides. So if I highlight my 2 sides that are matching, so there's 1 side and 1 side, and then I've got the other 2 corresponding sides, notice that my angle is right in between them. So the angle is made up of those sides, okay? It's the angle including those sides. So in this case, because I have AC congruent to XZ, I have BC congruent to ZY, and I have angle C congruent to angle Z, then triangle ABC, so that's an if, then triangle ABC is congruent to XZY, nope, ABC, so I want XYZ. XYZ by side, angle, side. This one was by side, side, side. Okay. The next one, angle, angle, side. Abbreviated AAS. And in this one, you have any 2 angles and then the side not between them. So I've got angle, angle. I've got the other angle. And then I've got the side that is not between them. MO is between them. I want this side. RQ or PQ is the side between them. I want the other side. Okay, so that's going to be my angle, angle, side. And same idea, I'm not going to write out all the pieces. Moving a little more, we also have angle, side, angle. And this one is where people get a little mixed up because it's the positioning of that side that makes a difference. Again, I have 2 angles. So I have here and there, and I have this angle matches that angle. This time, though, I do want the side that is in between the 2 angles, okay? The side that the angles share. So that's going to be my side, angle. So make sure you know the difference between these 2. Angle, angle, side, the side is not between the angles. Angle, side, angle, the side is between the angles. That's why we list it the way we do. The last one that we need to know only works with right triangles. It's called hypotenuse leg, abbreviated HL. Hypotenuse leg only works for right triangles because a hypotenuse, if you remember from your earlier things, hypotenuse is the longest side of a right triangle, and it will be across from the right angle. Okay, so it's not just the longest side of a triangle, it's the longest side of a right triangle. So we can only have hypotenuse leg if we happen to have a right angle anywhere. Okay, so here we have our right angles, and hiding behind the letter, here we have our right angles. There's the hypotenuse of both of them. There's the leg in both of them. See if you can identify a few of these, and then we'll be done for today. Great. Have a good night.